Okay, guys, let's recap what we did with discovering the properties of trapezoids and kites. Okay, first the trapezoid, the isosceles trapezoid. Uh, the the trapezoid, whether isosceles or not, okay, is defined as a quadrilateral with one pair of sides parallel. In our case, DC and AB are parallel, and they are what we call the bases. Okay. Uh, More specifically, the isosceles trapezoid is the trapezoid which additionally has congruent legs. So the legs are BD and AC. So that is a definition and a property of the isosceles trapezoid, that it has congruent legs. Okay. Um, so we of course saw that by taking the measurements here of this of the sides, that we do have two sides which are equal. Okay, and the isosceles kind of comes from the isosceles triangle. In fact, you can see I can force this thing into becoming an isosceles triangle. And if it is an isosceles triangle, as it is here, then we know by definition isosceles triangle is, okay, a triangle with two sides equal and their opposite angles equal. So in a sense, it's no surprise that when we pulled this apart and made it into a trapezoid per se, that in fact we found that there were equal angles. And the angles that occur to be equal are the base angles. So, and we have two pairs of base angles, okay? So we have the angles at A and B, which are the base angles for base AB, and they are congruent, as you can see here, at 38 degrees each. And the upper base angles at D and C, which are also congruent, okay? So thus far, again, we know by definition of a trapezoid, it has parallel bases. By definition of isosceles trapezoid, it has congruent legs. Additionally, it has the base angles equal, okay? The base angles equal, okay? And if I were to illustrate something a little bit further for you, okay, if I were to look at the line that's contained here, okay, and kind of show you that line in red, and then put another line down here, okay, then it would be of no surprise that the angle here at C and the angle here at A just are, in fact, same side interior angles. So here's the transversal coming into play right now, okay? So as you can see, with the parallel lines there at in red, this segment here, or the line CA, and we'll display that in yet another color just to illustrate that, is a transversal. And as a transversal, cutting through two parallel lines, we knew that same side interior angles were congruent, same side, or supplementary rather, same side interior angles are supplementary. Then it's no surprise that we would find that angle C and angle A are supplementary. And we're tagging them as the non-base adjacent angles are supplementary. Likewise, I could illustrate that over here with B and D, that they are likewise, okay, non non-base adjacent angles, and I think we saw there that those angles add up to 180. Okay, here you can see clearly 141 and 39 at C and A. Likewise at B and D are supplementary. Okay, and lastly, okay, we find that the diagonals, when we constructed the diagonals, that the diagonals were congruent. The diagonals were congruent. So five very important properties for the trapezoid, the isosceles trapezoid to remember, okay? One set of parallel sides known as the bases, okay? The bases are always tagged as the parallel sides. The non-parallel sides for the isosceles trapezoid are the legs, and they are, as you can see, congruent, okay? The base angles, there's two pairs, the lower base and upper base, if you will. The base angles are likewise congruent, as you can see here. and as you should have seen with your construction, and the lower base angles are equal and the upper base angles are equal. The non base angles, which are adjacent, are supplementary, as we pointed out, in as much as they are same side interior angles of formed by transversal and two parallel lines. And lastly, that the diagonals are congruent. So there are properties of our isosceles trapezoid. We have to remember them, and next we will apply the algebra to them.